following the thresholding example, I'm just going to go through a few more different types of segmentation. Again, I'm not expecting people to memorize any mathematical formulas. You need to understand the principles of what's going on. So we saw in thresholding, if you're below one threshold, it's background. If you're above the threshold, greater than or equal to the threshold, it's foreground. So on this MITK workbench, we have other options. So a simple enough extension is to put two thresholds, an upper lower threshold, so you can be between a range. That's fairly self-explanatory, I'd hope, and it kind of depends on, again, whether the thing you're trying to segment fits between those range of intensity values. But one that is worth having a quick demonstration of is called Otsu or OtsuThresholding. So if I create a new segmentation, I'll just put test. And again, I select a thresholding plugin. So this one is OtsuThresholding. OtsuThresholding uses a histogram. So if you look in the CT scan, you can see we have lots of background images that are dark. We have bright pixels that typically in a CT scan represent bone very often. And then we've got this kind of mid-grey. So you can imagine a sort of world or a histogram where you have peaks around certain values. So the idea of the OtsuThresholding algorithm is to work out these thresholds automatically as sitting between these peaks of intensity distributions. So if I imagine here, I've got basically three types of peaks here. I've got the background, the mid-range and the high range. So in this plugin, I set the number of regions to 3. If I go preview, the algorithm is running, and you can quite clearly see here, it's actually quite quickly divided the image into 3 specific categories. It's worked out that most of the background, and it's labeled it exterior. So exterior to the thing in the middle of the image. You can often do this not only because it's the lowest pixel value, but it's also the lowest pixel value right next to the edge. And then it's found 2 thresholds that seem to correspond to different things in the image. So if I select object 1, you can basically see that it corresponds to that kind of mid-range value. And if I select just object 2, it's the high range value. So automatically thresholding and picking out the maximum within class variance does seem to give us a relatively nice segmentation on a CT scan. I can then, I believe, pick which one of these segmentations I want, and if I click multiple objects, I'll join them together. So let's click object 1 and object 2, and if I go confirm segmentation, MITK will convert it to red. That's mean it's kind of in the bag, it's confirmed. So instead of just looking at bone, I've now kind of got bone and all the soft tissue. So I can again, if I generate a polygonal model, I quite like looking at them in this 3D window. Look at this 3D, it's semi-transparent, so I'll just make it fully opaque. And there you can see I've actually got already quite a good representation of where the edge of the skin was, and you can also then see it overlaps with whatever head holder the patient was placed in. I suspect that the patient was in some kind of foam block on their head, holding their head in a sort of position here. These are typically some kind of polystyrene type foam. So there you can see quite simply an overview of what OtsuThresholding does for you. It automatically selects thresholds based on a histogram. But essentially it is still a thresholding mechanism. There's no clever knowledge built into the algorithm of what you're actually thresholding. It just looks at the histogram and then classifies pixel values directly. That's OtsuThresholding.